I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will see the topic capacitance of isolated sphere and spherical cells. So consider a spherical capacitor for the first case of finding the capacitance. So consider a spherical capacitor formed by two concentric spherical conducting shells of radius A and B. The capacitor is shown in diagram, and the radius of outer sphere is taken as B, while the radius of inner sphere is taken as A. And here B is greater than A. The region between the two spheres is filled with a dielectric of permittivity epsilon. So the inner sphere is given a positive charge plus Q, while the outer sphere is given by the negative charge minus Q. So this forms the capacitor. So consider a Gaussian surface as a sphere of radius r. It can be obtained that E vector is in radial direction and is given by the electric field vector E is equal to Q by 4 pi epsilon r square AR vector volt per meter. So here r is the radius and epsilon is the permittivity, AR is the unit vector, Q is the charge. Now for the spherical capacitor, the voltage, that is the potential difference, the work done by moving a positive charge against the direction of electric field, that is from R is equal to B to R is equal to A. The formula is given by E is equal to minus integral minus 2 plus E dot dl, or we can write this as integral of R is equal to B to R is equal to A minus Q 4 pi epsilon R square AR vector dot dl. So by integrating, we get the voltage difference or the potential difference V is equal to Q by 4 pi epsilon 1 by A minus 1 by V, that is in voltage. So now the capacitance can be easily calculated from the formula of total charge by total potential difference Q by V. So Q by 4 pi epsilon naught 1 by A minus 1 by B, and Q get cancelled in both numerator and denominator. So the final expressions for the capacitance is given by 4 pi epsilon naught 1 by A minus 1 by B farads. So now we are going to calculate the capacitance of a single isolated sphere. So now consider a single isolated sphere of radius A given with charge plus Q. It forms a capacitance with an outer plate which is infinitely large, hence B is taken as infinite. So the capacitance of this type of single isolated spherical conductor can be obtained by substituting B is equal to infinity in the equation. So we get C is equal to 4 pi epsilon naught 1 by A minus 1 by B, 1 by infinity. But we know that 1 by infinity value is 0. So it is substituted 0 in the formula. So C, the capacitance can be obtained as 4 pi epsilon A in farads. So this is the case of spherical conductor at a large distance from the conductors, and practically this fact is very important in obtaining stray capacitance of an isolated body. And now we are going to see the next case, single isolated sphere but coated with a dielectric. So in this case, a single isolated sphere is taken and it is assumed as coated with a dielectric having permittivity epsilon 1 up to radius r1. The radius of inner sphere is A as shown in the diagram, and it is placed in free space. So outside sphere is epsilon is equal to epsilon naught. It carries a charge of Q. So now the radius r is in between A to r1, epsilon is equal to epsilon 1. And for r greater than r1, epsilon is taken as epsilon naught. And the potential difference for this case V is equal to minus of integral E dot dl from 0 to A. So it is obtained as V is equal to integral of E dot dl, and substituting in the voltage formula, electric field intensity is q by 4 pi epsilon 1 r square ar vector. So now the capacitance of single isolated sphere coated with a dielectric material. So for this type of sphere, it is C is equal to 4 pi 1 by epsilon 1 by a minus 1 by r1 plus 1 by epsilon naught r1 in farads. Now assessment, spherical capacitor, and we know it is the two capacitors separated by some distance, and this it is in spherical form, and the capacitance of a spherical capacitor, we have seen it is C is equal to 1 by 4 pi epsilon naught a f when it is single isolated sphere, and it is 4 pi epsilon by 1 by a minus 1 by b farads for spherical capacitor. Thank you.